Hello everyone, today we're going to be doing 2014 Aime Ii problem 7. Now looking at this first, it looks really complicated. Like we have f of x, a quadratic to the power of a trig function, and then a summation of a bunch of logs with an absolute value around it. Like what is going on? But it's actually not as hard as it looks. So let's break it down first. Looking at the logs, we can write out like the first few terms of the summation. We would have log 10 of f of 1 plus log 10 of f of 2, and so on. But because of log rules, we know that this will condense down into log 10 of f of 1 times f of 2 all the way to f of n. So that's what we're going to take the absolute value of, and we want this to equal 1. If we want this to equal 1, then that means that our inside has to be either 10 or 1 over 10. Because if it was 10, that would give us 1, and then if it's 1 over 10, that would give us negative 1. And you're taking the absolute value of that. So let's look at the function itself now. We know that x squared plus 3x plus 2 factorizes into x plus 1 times x plus 2. And this is raised to the power cosine pi x. So let's plug in the first few values of x into this exponent here. Whenever we plug in 1, we get cosine pi, which is negative 1. And when you plug in 2, you get cosine 2 pi, which is 1. And as we keep going, we see that all odd numbers of x will give you negative 1, and all even numbers give you positive 1. So if x is odd, then the exponent is negative 1. If x is even, then the exponent is positive 1. So if we expand this out and put it into our summation up here, this will give us log 10 of, starting with x equals 1, we would have the exponent of negative 1, which means we would have the reciprocal of it. So that would be 2 times 3 at the bottom. Next, for f of 2, we would have the exponent of 1. So we would have 3 times 4 just as itself. And it keeps alternating. And so on. And this looks like something we can do. This is just going to telescope. Like we're going to have these terms cancel out like that, and so on. And now we want to find when the inside will equal 10 or 1 over 10. Starting with 1 over 10, I know that I can get 1 over 10 by doing 1/2 times this 5 over here, which means if I end my sequence here, then this cancels out and I'm left with 1/2 times 1 over 5, which is 1 over 10. So that would be 1, 2, 3 terms. So that means that n equals 3 is one of our solutions. The second one, when the inside is equal to 10, we know that everything other than 1/2 telescopes. So if we want to multiply 1/2 by something to equal 10, that means we have to multiply it by 20. So we keep telescoping until we have 20 in the numerator. That will cause 1/2 times 20 to be 10. So if we keep writing out the terms, we get to the term where it's 19 times 20. And based on the previous terms, the 19 and everything else before that will cancel out, leaving us with only 20 on the top. So then that would give you log 10 of 10. So which term is this? Well, we can just count it out, or we can just plug in here, and since this would be equal to 20, that means x is 18. So we have n equals 18 as our second solution. And that's it, because our inside can only be 10 or 1 over 10, and we already found the n values for both of them. So now we just do 3 plus 18, because it's asking for the sum of all the integers n, and that gives us 21. And that's our answer. Thank you. Have a nice day.